Okay, imagine seeing this headline. It just sort of grabs you. 15 cities that could be underwater by 2030. It sounds like, I don't know, something straight out of a movie, right? Global warming. It often feels like this huge abstract thing, a problem for later. But predictions like that, they really pull the future right into focus, makes it immediate. So today, in this deep dive, we're going to look at the reality behind those kinds of headlines. We'll explore how cities, around the world are already dealing with rising waters. And then we'll get into some really visionary, maybe even futuristic solutions for living with water, maybe even under it. Our guide for this journey is a really interesting mix of sources. We've got articles from Time Out, Engineering, the Ground's Truth Project, Curiosity Unlocked, Ocean Builders, and also a bunch of blog posts, research papers, that kind of thing. Okay, so let's unpack this. Our mission really is to get a handle on the immediate challenge these cities are facing and also see what human ingenuity is cooking up to navigate this, water-filled future. Let's start with that Time Out article. It was pretty jarring. Paints a stark picture, yeah. Using maps from Climate Central, data from the IPCC's 2021 report, that's the Intergovernmental Panel on Climate Change, and these projections show which cities look most vulnerable by 2030. Now, it's important to say these maps aren't just like freak storms. They show future tide lines if we stay on the current heating path. Of course, adaptation efforts could change things, definitely, but the potential is still sobering.
Yeah, what really jumps out, I think, is how Climate Central makes this huge, abstract threat, global sea level rise, feel so real, so immediate. It's one thing to hear the stats about thermal expansion, the ocean water itself expanding as it gets warmer, or melting ice caps, glaciers. Those are the main drivers pushing the tides higher. But seeing familiar places on a map, potentially underwater, that hits differently. It's a much more powerful call to action than, say, reading a dense scientific paper.
Absolutely. And when you look at the specific cities on that list, it really drives it home. Venice, Italy, I mean, it's the classic example, right? Facing this awful twin threat. Seas are rising and the city itself is sinking about 2 millimeters every year. You can just imagine their flood defenses, like the Mosi barriers, getting harder and way, way more expensive to keep up. Then you've got Bangkok in Thailand. A study back in 2020 suggested it might be the worst hit, at least in the short term. It's only about 1.5 meters above sea level and sinking faster than Venice, actually. Yeah, 2 to 3 centimeters a year. And the soil there, this dense clay, makes it worse. Areas like Takam, Samut Prakan, even the main airport, Suvarnabhumi International, they're at real risk. But maybe the most extreme case we read about was Jakarta, Indonesia. 40% of the city is already below sea level.
40%.
Yeah. And parts are sinking incredibly fast, up to 10 inches a year in some places.
10 inches.
It's mostly land subsidence. They've been pulling out too much groundwater for years. And that's just made massively worse by climate change, rising seas, plus these extreme monsoon rains. The prediction is pretty grim. If nothing changes, Jakarta, nearly 10 million people, could be underwater by 2050. It really makes you think, if you lived there, what would you even do? Flood insurance. Or literally start packing.
That's the core question, isn't it? And it points to something tricky. Why it's so hard to nail down local sea level rise predictions. It's not just a simple global average spilling over everywhere equally. Look at the U.S. Northeast coast. For a while, it was considered a hot spot, right?
Yeah.
Sea levels rising 3, maybe 4 times the global average.
Right, I remember reading about that.
But then it sort of dropped back closer to the average. It shows this sea level variability. You can get these yearly bounces, maybe 5 centimeters, that's like 2 inches up or down. And why that happens, well, it's still debated by scientists. Early ideas pointed to the Gulf Stream maybe slowing down because of melting Greenland ice, causing water to pile up along the coast. But direct measurements haven't really backed that up. The Gulf Stream doesn't seem to be slowing, not yet anyway. So now the thinking is leaning more towards local weather factors, things like coastal currents, winds, even atmospheric pressure. These seem to account for maybe a quarter to even half of those year-to-year changes in places like New England, which makes predicting things precisely long-term almost as tough as, predicting next week's weather.
Okay, so we've got these stark predictions. It feels a bit overwhelming, but let's shift from the what if to the what now. How are cities actually responding? Is there like a fundamental shift in how places are tackling this, the ones that are getting it right?
Well, Boston seems to be taking a really proactive stance. Quite interesting. You have big companies like General Electric. They're not just worried about their waterfront investments. They're building differently because of it. New developments, like one called Clippership Wharf, they're literally pulling back from the water's edge, creating these living shorelines. Things like tide pools, salt marshes as a buffer.
That's smart, working with nature, not just against it. Exactly. And new apartment buildings. The ground floors are being built higher and higher. Clipper Ship Wharf's apartments, for instance. Their ground floor is a full 4 feet higher than a building finished just 2 years before it nearby. And it's not always because regulations demand it yet. Developers are doing it because, well, as one put it pretty bluntly, no one wants their investment underwater. Makes sense.
And connecting that to the economics,
Yeah.
it really is a smart investment. There's a professor at UMass Boston, Paul Kirshen, who estimates that every dollar spent on this kind of adaptation could bring back somewhere between $4 and $20 in economic benefits down the line.
Wow, that's a significant return.
It is, even though we're talking billions needed globally for adaptation. Boston's plan? Climate-ready Boston. Someone even called it the Moneyball of climate analysis.
Moneyball, like the baseball thing.
Yeah, meaning they're using data really rigorously to make the smartest bets, the most effective investments for resilience.
Okay, let's hop across the Atlantic. The Netherlands. They're the masters, right? Been managing water forever.
Absolutely. Centuries of experience.
Their history with dikes goes back to the 12th century. And their modern government basically evolved from these medieval water boards. Yeah. The scale of their projects is just mind-boggling. Like the Maesland storm surge barrier.
Oh yeah, that's incredible engineering.
Biggest mobile barrier in the world. Built for a storm that might happen once in 10,000 years. Cost over $500 million.
Has it ever closed?
Only once, apparently, back in 2007. And they've also got this massive 14-meter-high seawall protecting the Maasvlakte port expansion. Just huge defenses.
But what's really fascinating, I think, is that the Dutch aren't just building bigger walls anymore. That's the old way, partly. They've embraced this different philosophy. They call it room for the river.
Room for the river. Okay, what does that mean exactly?
It's a fundamental shift. Instead of only fighting the water back, trying to contain it completely, they're strategically allowing it to spread out to designated areas when river levels get dangerously high. It's about working with the water's power, not just trying to conquer it. A kind of coexistence.
And that approach, room for the river, it has real human consequences. You see that clearly in a city called Nijmegen. They had these terrible floods in 93 and 95. That was the big wake-up call. Led to 200,000 people being evacuated.
Huge disruption.
Yeah, and as a result, dozens of families had to move. Their homes were in areas needed for floodplains. We read about one couple, Frank and Monique Plum. They took a buyout, built a new house, taller, on stilts, just across the river. And there's this other big project, the Noordwoord depoldering.
Depoldering, so like giving land back to the water.
Exactly, reversing the polder process, letting areas that were once reclaimed farmland flood again naturally.
Right, so this Noordwoord project restored about 25 miles of creeks. Sea eagles even came back, which is amazing. But residents like Anneke van Lelyveld, she talked about dealing with 4 years of nonstop construction, losing neighbors. Her feelings were really mixed, sadness for what was lost, her community changing, but also this deep pride in what the Dutch were achieving, protecting the future. Now, let's go back to Jakarta. We talked about its really unique, severe challenges. All right, the sinking city.
Yeah, and their proposed solution, this $30 billion National Coastal Development Plan, it really highlights the tough choices. It involves a massive 300-mile seawall, plus building artificial islands. And the plan is to finance it by leasing that new land to wealthy developers.
Okay. I can see where this might get complicated.
Definitely. It sparked huge pushback. Local fishermen, like one guy named Kuet Wibisono, they actually sued to stop construction. They argue it completely destroys their fishing grounds, their livelihoods, and they claim there was basically not any discussion with the community before it all started.
And that's a pattern we see often, unfortunately. These massive engineering fixes, they can create really significant social problems. In Jakarta, trying to make room for the river, similar to the Dutch idea, but in a very different context, it's led to forced evictions. Maybe up to 100,000 Riverside residents pushed out, even though many had land titles going back generations.
100,000 people, that's staggering.
It is. And the human cost is immense. We read about one woman, Fitriani, given just 4 months' notice, lost her way of making a living, ended up in a subsidized apartment that apparently leaked badly. There was a journalist, Evie Mariani, who suggested these relocations are maybe partly an excuse to clear out poorer areas and make Jakarta seem more upscale and touristy, basically sacrificing vulnerable people's well-being. It really underscores the lesson. Try to adapt early, incrementally if possible. Because waiting often leads to these drastic mega engineering solutions that have such heavy, often unfair social costs.
But, amidst all those tough challenges in Jakarta, there's also this really cool, optimistic adaptation happening. It's called Petta Jakarta.
Petta Jakarta. Tell me more.
It's an open source, real-time online map, and it cleverly uses the fact that Jakarta is apparently like the world's capital of Twitter activity.
Yeah.
So when there's a flood, people tweet banjir, that's the Indonesian word for flood, along with a geotagged photo. It turns millions of ordinary residents into this huge network of human sensors reporting flood conditions in real time.
Wow, that's crowdsourcing disaster data. Very clever.
Exactly. And the benefits are huge. The information is often faster, more detailed, more reliable than official reports. Even city officials, like one guy, Anto Sugianto, they use the map to figure out where to send pumps, when to close roads. It's actually been held up as a model for disaster response by the US FCC, the Federal Communications Commission, and the Red Cross Red Crescent.
That's a fantastic example of low-tech, high-impact community resilience. Really impressive.
Okay, so we've talked about fighting the water, adapting to it, but what if we just completely changed the game? What if instead of just fighting it, we started living with it? Or maybe even under it? Now we're getting into some really fascinating, almost sci-fi concepts. I mean, underwater cities, right? It's captured our imagination forever. Jules Verne's 20,000 Leagues Under the Sea, movies like Aquaman.
Classic trope.
But these ideas, they're starting to shift from just fantasy towards something maybe feasible, driven by, advances in technology, but also these big concerns about climate change, overpopulation on land. Take Japan's Ocean Spiral project. This is from the Shimizu Corporation. The design is wild. A giant floating sphere, maybe 500 meters across, connected to this spiral structure that goes down more than 4,000 meters deep into the ocean.
4 kilometers down. Incredible.
Yeah, and the idea is it's a self-sustaining city for thousands of people, taking pressure off land resources.
What's really ingenious about the ocean spiral concept is how integrated the sustainability is.
Yeah.
Take the power source. It's designed to use ocean thermal energy conversion, OTEC.
OTEC, how does that work?
It basically uses the natural temperature difference between the warm water near the surface and the much colder water deep down. You can use that temperature gradient to generate electricity, clean, runs 247 zero-carbon emissions. And Japan, with its deep ocean trenches nearby, has a really good temperature difference, making it ideal for OTEC.
And it's not just power, right? The self-sufficiency goes further. They plan to get fresh water through desalination, grow food using aquaponics, marine farming, even potentially mine rare minerals from the seabed down there. You could see it being used as a research hub, maybe a disaster recovery base, or even, I guess, unique ecotourism.
It definitely sparks the imagination, but it also raises huge questions about the challenges, right? The engineering hurdles alone are massive.
Yeah, I was wondering about that, the pressure down there.
Exactly. You need major breakthroughs in pressure-resistant materials, high-strength concrete, maybe carbon fiber composites, plus incredibly reliable life support systems, getting oxygen from seawater, recycling absolutely everything, and the cost. The estimate for just a working model by the mid-2030s is around $26 billion.
$26 billion. Wow.
Yeah. So a project like this needs more than just technology. It needs huge public trust, probably small pilot projects first, and definitely massive public-private partnerships to even get off the ground, or rather into the water. It's not just building it, it's making it truly viable, livable long-term.
Okay, so underwater is one vision. But another idea gaining traction is floating cities.
Right. Living on the water rather than under it.
Exactly. And the Maldives floating city is a really interesting example. It's actually being built inspired by the shape of brain coral, apparently.
Nature-inspired design.
Yeah. And the advantages seem pretty clear. Adaptability, first off, it just rises and falls with the sea level, naturally flood-proof. Plus, big focus on sustainability, eco-friendly materials, solar power, water filtration, systems to handle waste in a circular way. It's even designed to help marine life, with artificial reefs built into the structure. And they're aiming for self-sufficiency, too, generating energy, growing food with hydroponics. These projects, whether deep underwater or floating on the surface, they really feel like they could represent a new direction for cities, where we're figuring out how to coexist with the ocean, not just constantly build bigger walls against it. So we've covered a lot today, from those stark warnings, cities potentially vanishing underwater, to these really ingenious ways people are adapting right now, and even these, futuristic visions of living with or under the sea.
Yeah, looking at the big picture, it's clear, isn't it? The challenge of rising seas is immense. It's complex, no doubt about it. But human ingenuity, our ability to adapt, that seems equally vast. Those predictions for 2030 or 2050. They're not just deadlines hanging over us. You could see them as invitations to innovate, to rethink how we live, and to create solutions that maybe redefine our whole relationship with the planet and its oceans.
For thousands of years, humanity's looked up, right, to the stars, dreaming about our future out there. But this deep dive, it makes you wonder, maybe the next great frontier isn't just out there. Maybe it's also deep down, beneath the waves. What kind of world will we choose to build, or maybe let sink in the decades ahead?